Okay, good morning everyone. So today's lab is a resistivity lab. The purpose is to measure the resistivity of certain elements. Now we have two conducting wires here. You can see these are thin conducting wires about 1 foot long each, made out of some kind of material. So the goal is to find the resistivity of these conductors, right? So first of all, I want you to think about um, the terms resistivity and resistance. They're closely connected, right? Resistance is something we can measure using a ohm meter or using a multimeter. Um, Resistivity is a material property. So given a conductor like this, in this case what we have is a cylindrical linear conductor, right? It's about a few centimeters long, has a very small cross-sectional area. What are the factors that determine resistance of this? The answer is it depends on material properties, that is resistivity, depends on the length, and depends on cross-sectional area. So I want you to think about the equation that connects all these: resistance, resistivity, length, and area, right? Okay, so how do we find the resistivity? So we're gonna set up an experiment. Well, before that, very easily we can take a meter. Put it into resistance scale, and let's take the two probes, place it on either side of this, measure the resistance, measure the length, and measure the cross section, plug all this into the equation, and we can find the resistivity. So that's one way of doing this. The other method is, we're not going to directly measure the resistance. That's this lab. We're going to figure out it in a different way. The other method is finding the current and voltage across this conducting wire. This acts like a little resistor, right? Even though it's a good conductor, there is some resistance in it. So when we have current going through it, there will be some voltage, there will be some current. By measuring those, we can calculate what the resistance is. Okay, so next step is think about how to connect this into the circuit. Now here we have batteries, additional resistors, so we're going to use all these. We're going to build a little circuit. So let's see what this looks like. Okay, so going back to what I was explaining, so we have this thin conductor. Let's say the length is L, and there's some cross-sectional area. The resistivity is given by letter rho, resistance R, and there's an equation that connects all this. That is something you need to work on. So if this is the conductor again, we can take the meter, put it into ohm scale, let's say the ohm scale, place it across the two probes like this, measure the resistance directly, and from that you can figure out resistivity. Now let's say I want multiple readings, right? This is just one measurement. So what I can do is I take the meter, put it into ohm scale, I place one end over here, and then the other end I place it over here, take one reading. Then I slide it over here, so the length changes take another reading. So I change the length of this conductor. I measure the resistance at different points. So when I change the length, the resistance changes. That way I have multiple readings. I place the wire over the probe over here, so I have a different length, right? So L1, L2, that is from here to here, L3 from here to here. Like that, I can slide this probe along the length of the wire, take multiple resistance readings. That way I have multiple resistivity values. Probably I can take the average as the answer. Okay, but then I told you that we're not going to measure the resistance directly. One reason is actually the multimeter is not that sensitive when it comes to measuring resistivity, small values. These resistances are very small. So what we're going to do is, we're going to build a circuit where we will be measuring voltage and current instead of resistance, and then figure out the resistance. Alright, so I want you to take a minute, think about it, how to build this circuit. What do I need to do here? So here's a suggestion. So this is the circuit we're going to build, right? So we take a battery, connect this conductor over here, we can put an ammeter here, measure the current in the circuit, and we take the voltmeter, place one end over here, and I can place, let's say, the other end over here. Now I am measuring the voltage from this point to this point, and I have the current through the circuit. The current does not change, whatever that milliamperes or amperes, that does not change, right? When I measure the voltage, this whole wire is a resistor, right? So inside there is a resistor. The wire has some resistance in it. So when I place it at some point, I'm getting the voltage according to that point, according to this piece of resistance. So I have that voltage V1, I have the current, I can use Ohm's law, V equals IR, current I. So divide one by the other, I get the resistance of this segment. This is segment 1. Then I slide the meters, probe, and put it over here. So that is segment 2, right? Number 2. I measure the voltage. Current technically should remain the same, and divide voltage by current. So here I get one resistance value, get another resistance value. So like that, I can change the length, get multiple resistance values. Alright, so that is the circuit we are going to build. So let me show you what it looks like when you build the circuit. Okay, so here we have two types of wires, so we'll be using both. So in activity 1, we're going to use this particular wire, right? It looks like a silver color wire, so let's call it silver color wire, right? So we're going to use this. Take the circuit board. Again, I'm going to give you all the readings, right? So you don't have to worry about the numbers on the meter. I'll give all that to you. Take the wire, connect it like this, connect it like this, and take another wire, goes here, goes here, and now I have the circuit. I'm not connecting it right away, I'm just going to leave it aside. But if I connect these two places over here, I have a complete circuit. I can put the ammeter inside and I can take the meter. Okay, let me do this. Let me connect this to the switch. That way I have more control over this. This goes here, and then from the switch comes here. There you go. Now we have a complete circuit. We can attach an ammeter. Then we can take the meter, take multiple measurements at different places. So you'll see what I'm talking about. Turn it on. And I can measure the voltage at different points. Like I can measure it at some length like this. I can bring them closer. Or I can start from one end and slide this one here, 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 that, right? So that's one way of doing it. Now, that works, but there's a little issue. I want you to think about what is the issue is. What is the problem connecting this conductor directly to the battery? What can go wrong? So think about it. These are the discussion points. Now this wire is a good conductor, right? This is a good conductor. Rest of the circuit also has just conducting wires. So what I do here is I have the battery, and then I connect the battery directly back to its negative terminal, right? Positive to negative using just conductors. What can go wrong here? Because these are good conductors, it's gonna draw a lot of current. There is no control over current here. It's gonna draw a lot of current that can heat up the things. Could be bad for the wire. It's bad for the battery as well. It's gonna drain the battery really fast. I won't even have time to make any readings. So how can we prevent that? Again, points to think about. What do we do? So what we do is we will insert a resistor in series into this circuit. So here's the conducting wire. This segment is the wire. And then we're going to put a little resistor. And we have the ammeter also. So this resistor will actually limit the current in the circuit. Now we can have the voltmeter. Place it here and at different points like this. Along the length of the wire, we're going to take multiple voltage readings. We will monitor the current also. And that way, we can have multiple resistance values, and we can calculate the resistivity, right? So, we're going to build the circuit that way. So, real quick, I'll show you what I do. So go back here. Instead of directly taking current out, what I do is I'm going to put it here, and I'm going to take it now. The current goes here, comes out. I'm going to use one of these resistors. Now I have the circuit. Now we turn it on. We can measure the voltage at different points. There's one here, one here. I see a couple of millivolts. I can drag it along the length of this. I see that changing. Okay, you won't be able to see the numbers. It's changing fast. It doesn't record that fast. So therefore, I already have the numbers recorded in the table. I'm going to give you the answers. Alright, so let's go back to the board. Okay, so this is the circuit we have. Let me redraw it. the wire. So this part is the wire. From here to here, this is like another resistor, and then the resistor is inserted, the ammeter goes back, and the voltmeter over here. This also, the wire also can be represented as a resistor. Now for activity 1, we make measurements starting from 4 centimeters. All the way we go to 24 centimeters. We have about 6 data points. This is the silver color wire, so let's just call it silver. It's not made out of silver, okay? It just looks like it's like stainless steel or aluminum looking wire. One information you're going to need is the cross section, the diameter, the area. So I'm going to give you the diameter of the wire. Diameter of this is 1 millimeter. I will give you the data table separately. So we will be measuring voltage at different points. For the activity 1, I will give you voltage and current information. I'll have a separate table attached. Alright, so that's activity 1. Activity 2, same thing. We have a different wire. It's only just a different wire. This one over here, it looks like a copper or gold kind of color. So all we do is change the wire, put it here, and make the same measurements, right? We measure the current, we measure the voltage along the length of it, and that's it. One more thing I want to add. When I take in actual data, I use something a little different setup. I use this thing. This is called the resistivity box. The only thing is, this is not any fancy instrument. It's just make it easier for me to keep the wire in place, right? I can just insert the wire here, attach it firmly. It has a inbuilt scale over here, so I can read the length easily. There is so I can take the probes, just place them here and there, and measure the length between them. There are connections. I can connect it to the circuit board easily. Even it has a slider, so I can put the meter probe over here like this, and then I can slide it. So it makes things very convenient. That's all, right? So when I'm taking actual data, I will be using this box, okay, the resistivity box, but it doesn't make any difference to the activity. All right. So let me move this. When we go to activity 2, again I will give you the data table in a minute. Activity 2, again we are going from 4 to 24 centimeters. It's the gold looking wire. Diameter is 0.5 millimeters. Okay. All right. Now you have once I give you all the data points, you have your data. Now what's the next step? How are we going to calculate resistivity? So let me clear this. Actually, I don't have to clear it. I will tell you what we need to do. The goal is to find this resistivity. What we calculate is resistance, and you know how to connect resistance to resistivity. We have the length, we have the cross-sectional area. Using that, we can go from resistance to resistivity. So what I want you to do is draw a graph. Now this part is totally up to you. What kind of graph? So you have multiple resistance values. You have multiple length values. Try to put these into a graph. Could be a y equals mx type of graph where you get a straight line. It could be something that gives you a curve. But the whole point is finding the resistivity using the graph. You're not going to calculate it directly. You're going to use the graph, maybe use the slope of the graph to figure out the resistivity. Now, this part I'm not going to help you too much. I want you to give it some time, give it some thoughts, and try to figure it out. So we have multiple data points, right? Multiple resistance values, multiple length values. Think about a way to plot them. What is your independent variable? What is your dependent variable? When you plot them, do you get a straight line or do you get a curve? If you get a straight line, what the slope of the straight line means. It's not that difficult. With some thoughts, you'll be able to plot this and you'll have a nice looking graph. From that, figure out the resistivity. So in your lab report, you're going to draw the circuit diagram, the one that we have here, draw it nicely. You're going to explain what you did. You're going to show your data, which I'm going to send you separately in a minute. Show your data. Show your calculations, how you find the resistance, how you find the resistivity. Show the graph and add a little explanation how you find the resistivity from this graph. Finally, once you have that resistivity, do a little Google search and see what kind of material, what kind of element is this, because resistivities are unique. This number you find should match to online databases and you'll be able to make a good guess what is this material is. Okay, so you're going to do that for activity 1 and activity 2. Alright, that's all. If you have any questions, you can email me, you can talk to me in class, and I'll be happy to help.